Good afternoon. Welcome to Making Stuff with Chris Dayhut. This is a continuation of the series of the ZOOMTOWN experiment. For today's video, we're going to be covering the trip plan, and that is the set of instructions that are created over at the scheduler. We right now manually create the trip plan there, selecting which roads to travel in which order, and then it figures out all the actual motion commands at the scheduler, communicates it over to the Zoomie, at which point it will interpret all those instructions and execute them by driving along the path. Now this is potentially going to be a long video. I'm going to try to talk fast and try to cover things. I'm also going to provide a document that I will post in the source code area of the website so that you can go pretty much, that's going to be my script for it. It's an outline of the different types of motions and what is needed to perform that, and then the command structure for the trip plan itself. For all of this to happen, we're going to start over at ZOOMTOWN. I'm going to program a real quick trip plan. We'll execute it, and then from there we'll start diving into the actual trip plan instruction set. We're going to keep this trip plan a little bit on the short side, but hopefully with enough maneuvers in it to make it interesting. So we're here with the Zoomie sitting in destination 31. I'm going to go north on road 21, west on road 4, north on road 19, west on road 6, and we'll park over in destination 17. We will process that trip plan, and then I'll simulate it to see what it looks like. And that looks complete. With that, I'm going to say select Zoomie and run. I can see, hopefully the overhead camera can pick that up, but I've got my flashing red lights indicating the trip plan is in the Zoomie. I could see it show up on the other monitor that's connected to the Zoomie with the umbilical cord, and we'll let her go. And with that, the trip was programmed, tested or verified, and executed. Now what we'll do is we'll move back to the other computer where I've got all the documentation, and we'll continue filming over at that spot. Back at my main workstation, we're going to take a look at, very quickly, the trip plan that was created in the scheduler. And that would be all of this code here. You'll see that these indices on the left, those are just printed out to show me which line number that is. The actual command line or code that we're sending is this area right here between the square brackets. And all of the trip plans start with BEG representing beginning. There's a total of 10 parameters in here for each motion command. And it was 19 total motion commands to execute that trip plan. So that's what it looks like pretty much in the raw format. And then that is, when I process it over there to transmit to the Zoomie, it goes through the MQTT transmission. And that's what we see here printed out. And it's just showing me which Zoomie it was going to here. And then this again is just my line counter as it's processing the information. But it's a very simple motion command language working well within our ZOOMTOWN. It takes advantage of all the capabilities on it. Well, of course it did. It was designed together, so it does take advantage of everything that's there. So the purpose of this video is to understand this from the creation point of view and what it means. And there will be two sections to that, because the trip plan isn't just about the codes to make it move. As you remember, when I programmed it a few seconds ago here, I select the road numbers, and you'll notice that on the Zoomy layout, or on the ZOOMTOWN layout, not all the roads actually connect to one another. There's missing areas. That has to be accounted for. There's certain areas where we've got to stop and then continue. Certain areas where I got to pivot turn left, pivot turn right, pivot turn left or right in reverse. There's a whole lot of other stuff going on besides just going along road 19, 4, 16, and 9, etc. All these extra little moves have to be generated along the way. So with that, let's go to that part of this document. And again, I remind you that this document, I'll do a PDF output and provide it when the video is published, and that document will be on the companion website, makingstuffwithchrisdayhut.com. So again, we're looking at the scheduler side of the trip plan, and what we're going to look at is combined motions in this section. Every motion, every road I drive down the road, or I back out of the driveway, but then there's following steps that have to occur in order to get lined up to make the next road movement. Backing out of the driveway is a multi-step operation, here in ZOOMTOWN as it is in the real world. Let me move the model through that motion first, and then we can understand what these codes mean a little better. As you can see, I need to stop before backing up, and that stop command is saying that the Zoomy has to sit here and wait until it gets clearance from the scheduler to start moving. That's so that it doesn't hit any cross traffic as it's backing out of the driveway. Then it can back out of the driveway with the BOD command and then make a pivot turn to get headed in the correct direction. Another condition of roads that isn't on this particular example that we programmed would be driving from one bypass road to another. Now in this case, the outer ring of ZOOMTOWN is the bypass road, and you'll notice that we've got large sweeping turns. So we would travel along a road, and then the added or additional extra move would be to move along that sweeping turn. And those instructions would be FLS, which is driving along or line following steering, and then the FLM was a follow line motion, which is primarily for these sweeping turns. The next area of intersection that we've got to deal with is we're going to enter the current road, and then we're going to follow that with a turn into the start of the next road. And that mid-road entry is very important because that's a flag. Whenever we have a mid-road entry, we need to have a preset position, which I'll highlight right here, and then that will in turn allow us to localize the Zoomy relative to that line. Otherwise, it doesn't really know where I am along that road segment. Now let me move the Zoomy through that so you can get a visualization. In this example, we're going to drive along the road, and we would have preset the location when we encountered our first magnet on the right sensor. Then when we're ready to turn, when we're at that location, we're going to stop. Again, wait for permission from the scheduler, letting us know traffic is clear. Then we're going to make a pivot turn left, and then we're going to use line following distance with an extended move to get across the traffic lanes. Now this next one, we're going to drive to the end of the road, turn into the middle of the next road. We would be moving along the current road. We would come to a stop. Then we would need to pull out into the intersection to get lined up to make the turn so that we can get turned in the correct heading for the next motion. And that's something that's kind of tricky to keep ahead of this. We need to execute the current road, but at the end of it, we need to be prepared for the next road. Now this next one, we're going to go over to the four-way intersection, and there we will go to the end of one road, stop, go across the intersection, and get ready for the start of the next road. And that uses the same commands as the previous operations. Next, we're going to drive to the end of a current road, then turn into the start of the next. This would be a pivot turn. And finally, one of the last combined motions that we have to do is get the Zoomie back into a driveway. So it will continue along a road, potentially with a preset value. It will then have to stop, ask for permission to turn into the driveway if it is crossing traffic lanes. In other words, making a left-hand turn. Remember, this is the US, and we're right side drive. Finally, it'll pivot turn into the driveway and then drive up to the barrier. And that is how all of this trip plan is broken down into these conditions of action, where we're backing out of a driveway or how we're interacting from one road to the next through an intersection. And we have to account for whether the current road we're on, if we enter it in the middle of the road or at the beginning of the road. And then that establishes our requirement for a preset. The preset establishes a localized position relative to that road, and it works in conjunction with the marker tape that's on the road every 1 inch, 25 millimeters, and with the magnets that are located along the right side of the Zoomie's path. Now let's move on to the trip plan function calls. This will help us understand how the functions are called, as well as the commands that are used for each of the trip plan instructions. Now this would be the same thing that we see coming through, transmitted via the MQTT. This would be the trip plan instruction, and there are 10 parameters there, and the meaning of the parameters can vary from the one motion to another. Some motions need to be told whether, like for example, a turn, either turn left or turn right, or the motion needs to either be forward or reverse. So the meaning of certain parameters changes with the type of motion that it is. Starting out with, we've got two non-motion commands in the trip plan. And again, this add function 2, this is just the call statement to adding the instruction to the trip plan. And these are the parameters we're sending to it. It'll take that data and convert it into a list for transmission. Now the BEG was the beginning of the trip plan. You'll see that there's a quote, 0 quote here. That is a string data, so I have to put some default value in there. For the numeric placeholders, I'm just using a value of 0. At the far right, the last two parameters will always specify the global position of the Zoomie at the end of the move, or where it currently is for a non-move. What is the global position? The global position is, if we go over here, this area here, in the top left-hand corner, this is x0, y0. Y positive coming down, x positive going toward the right. Just as computer graphics are typically laid out in that Cartesian method as well. So that is what you'll always see in these last two, and the letters will change only because of what I'm trying to communicate out of the scheduler when it's creating that, but the function at the far end is exactly the same. Now here we're going to add an instruction. That one would be our stop command. That requires permission to move. So that causes the Zoomy to stop. Before proceeding, the Zoomy must obtain permission to proceed, which is based on traffic being clear. And the only person that knows that is the scheduler. Finally, end is the end of the trip plan. A trip plan begins with the word BEG, ends with END. The next step is, or the next portion is the parking commands. We need to back out of the driveway and then we need to pull into the driveway. So reading through the commands here, BOD, back out of driveway. The distance to travel is from the road up to the barrier. And then we don't have a forward or reverse needed, so that's just using a default value of 3 dashes. There's a few parameters here that are not used anywhere, and those are just reserved for future. The heading of this motion while backing up will be communicated here, and again our global positions. It is important to note that the reason why this is such a special move, this move will also use the distance sensor along with encoder feedback to figure out how far the Zoomy has backed up as it's backing up out into traffic. It actually uses 2 sensors as opposed to just 1. Likewise, pulling into the driveway, PID command, we need to pull in a specified distance. And again, that distance is, we'll call it a recommendation. The Zoomy will actually do its best to position based on sensor data as opposed to what I'm commanding it there. Again, no direction is needed, a few blank variables, the pull-in heading as it's pulling into the driveway, and our global X and Y positions. Next up would be our typical line following straight motion commands. That would primarily be FLS for follow line steering, and then FLD, which is follow line distance. The difference being that follow line steering is going to go to the absolute position at either the end of the road or to some position along that line, and it's following the line to get to that position. This line or road may need a preset condition. At time of creation, I'm going to communicate to the Zoomy what the road number is that it's on, what its heading is, and then ultimately what its global X and Y position should be. This is probably one of the most complex functions in the system in that this FLS command is utilizing the marker tape. It's using the magnet for preset positions to also do all of the localization and position tracking. There's a lot going on in that function. The FLD happens at the end of a road where we're going to turn onto another road or go straight across an intersection. We need a way to account for that extra movement. Remember, the roads don't all touch each other on the layout. They stop at the start of any intersection. So you have to get across there. Those are all fixed distances. So in this case, we use FLD with an extend variable, which is simply the distance to travel, an incremental distance, not an absolute position. It's not using any marker tape or anything of that nature, so it's kind of really going purely on encoder feedback. And with that, we'll have the heading and at the end, the global X and Y position. We have 2 different types of turning commands. One is very specifically a turning command, and it's called pivot turn or PTL or PTR, pivot turn left or pivot turn right. That needs to know which direction it needs to move, forward or reverse. The only 2 times we go in reverse is to sometimes do a pivot turn or to back out of the driveway. You'll notice that there's no distance specified because it's always a fixed 90-degree turn depending which way you need to go, a left turn or a right turn. That is PTL or PTR. And finally, the heading at the end of the turn is communicated here along with the global positions. There's another type of motion that I had to create to get through the sweeping turns, which are from one bypass road to another bypass road, and that's FLM, follow line motion. It does a little different processing on positional data. The distance to travel only is required enough to get to a specific marker tape, which in the linear world would be a ½ inch from the end of the sweeping turn. The Zoomy is actually going to go up to that sweeping turn and then reset position and move up to the start point of the next line. So with that, we will have the distance to travel we need to specify, and then the heading at the end of the turn, and of course the X and Y position for the global coordinate system. Now, I know a lot of you had it in your mind that when you saw me actually click on like the destination start point, click there, click the road, click the next road, click the next road, and then the destination driveway, well, that was 4 moves. That's all it was needed. You probably didn't consider all the additional things that have to happen for the Zoomy to get to the end of the road, what to do when it gets there, and to get in position for the next road. I'm not telling that in that trip plan program or code generation. So that's why I felt it very important for you to understand what's going on over in the scheduler. And if you need, let me know and I'll do another video on the code, how this is all decided and processed in code. Now for the next video, what we're going to do is take that data from the point of entry into the Zoomy. We'll see the MQTT data coming in, and then from there I'll actually go through with an overview of all the functions that look at these commands and then finally execute them. Some of that we've already covered in past videos, but in bits and pieces, so I think it bears repeating at this time. So with that, we'll wrap up this video. I look forward to seeing you in the next video.